Okay, so now I'd like to pose a question to you guys. Can you come up with a mitigation strategy? Maybe one that would either make sense to you or that you've seen. What do you think?
Cross bracing?
Cross bracing. Nailed it. Right. So come up here and draw me what you think cross bracing would look like if we added it to this building. And in fact, why don't you use a different color of blue?
Can I just do this? Or do I need to make it more?
That's fine. That looks great. Okay, cross bracing. So cross bracing is the act of adding supports at an angle in between buildings, floors. Okay, so we're adding crosses as braces. Should make sense, right? Now, intuitively, I think this makes pretty good sense as to why this would help. We're certainly adding structure, we're adding strength, but in a more mechanical explanation, can you tell me why this accomplishes the goal of keeping the base of the building in line with the top of the building?
It might, I guess it increases the stability of the tension that might happen between the earthwork.
Okay, so you're using a couple of really good words. Specifically, the one that you used is tension, right? So basically, what we've done is we have changed these square shapes into triangle shapes, right? We always like to see cross bracing that has both of them there, but if we wanted to break it down a little bit, we could just add one and see that we've changed this square into two triangles, right? So why are triangles better than squares in this particular case?
I guess it would be less area.
Less area?
Right.
Not exactly. Let's take a look. And the way we're going to take a look is we are going to use our plastic craft sticks. So the first thing I would like you guys to do, if you have a partner, this would be an ideal time to have a partner. And if you don't, then you'll have to work it out at home. Is I would like for Brandon to hold these, and I would like for Lucy to hold those. And I'd like for you guys to make a square, each holding, there you go. Okay, now hold the other two edges. Brandon, hold here. Lucy there. Could I get the camera to come up so you can kind of see a little better? All right, so now we have a floor that's in the shape of a square, right? All right, and everything is bolted in and it's supposed to be very secure. Now, if we have movement of the bottom of this square, you guys see that it folds over fairly easy, right? Coming back the other way. And this is simulating an earthquake. Now, when it's in this position, we have gravity pulling down, and it will crunch down and the building will collapse. Now, let's look at it if we have a triangle shape. Can I get Lucy to drop this one? And there, no. Yep, there you go, that's good. Okay, so now we've changed our structural component to a triangle, okay? Now, if we try and move these, let's do it with the base on with the flat on the bottom. Now, if we try and move these, what you'll see is you always have one member of the structural component in tension and another one in compression. So now, if we try and move this, we see that even though we can rotate the structure, the shape does not collapse. So this is a very simplistic and very well-used idea behind lots of structural engineering, is that we use triangle shapes instead of square shapes. So by adding this, what we're doing is reinforcing very securely this member, not allowing it to collapse, and therefore not allowing the whole building to bend over. So I'd like you guys at home to kind of play with those and make sure that you understand the difference in the structural strength between a square and a triangle.